Okay, let me start by explaining what area is. Area is basically how many squares we can fit in a section. As an example, let me start with a rectangle. Let's say I had a rectangle and I have it broken down into squares. I'm gonna go this way. We can count the squares, right? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. So it's doable. Remember, area means how many squares we have in there. Okay. Now, there's going to be some formulas. Things are going to make it easier. One thing I can see is that, let me use blue. This side, this long side is 5 squares. This short side here, it is 3 squares. Now, the way mathematicians look at this, they said, I could be adding in groups of 3. So there's 3 plus 3 plus 3 plus 3 plus 3. But then we remember that repeated addition, right? When I'm adding the same number over and over and over, repeated addition is basically multiplication. So instead of adding 3 by itself 5 times, I'm just going to go 3 times 5. And that gives me 15. So like I said, I could count the squares or I could just multiply them. Now, interesting is that the 3 is one of the sides of the rectangle. The 5 is the other side of the rectangle. Sometimes we call those length and width, or sometimes base and height. Right? We call it base and height if the triangle is standing up. We call it length and width if the triangle is laying down. I'm just gonna call it the two sides that make a 90-degree angle. How are the sides called? It really does not matter. It's just the two sides that make a 90-degree angle for a rectangle. I'm just gonna multiply them out. So looking at question number 1, I look for a 90-degree angle. Got choices, right? There's 4 of them. It doesn't matter which one you choose. Just to choose one, I'm gonna choose this one on the top right. The two sides that make that angle is 7.7 and 6.7. So let me multiply that out. Use a calculator if necessary. So 7.7 times 6.7 gives me 51.59. On your homework, I'm going to say find the area of each and round it to the nearest tenth. So 1 decimal place. So here I have 2 decimal places. In this case, my second decimal place is big enough, right? It's a 9. So that's going to round up the previous number. So instead of 51.59, I'm going to call this 51.6. And that's it, right? When it comes to a rectangle, that's all we do. Now we have this figure that we earlier called, in semester 1, we called it parallelogram. It looks like a slanted rectangle. Interesting part, let me draw a parallelogram here. Interesting part of a parallelogram is if I was to cut a triangle on one side and move it to the other side, if I was to cut a triangle on one side of my parallelogram and move it to the other side, I create a rectangle. So I know how to get the area of a rectangle. When it comes to parallelograms, look like a slanted rectangle. When it comes to parallelograms, I'm going to treat this the same way I treat a rectangle. And like I did for question number 1, I said look for a 90-degree angle. In this case, I don't have many choices. It's right there. I'm going to multiply the 2 numbers that make the 90-degree angle. So one of the numbers is 7.3. The other number is 8.3. I know 8.3 is here, but if this dotted line means if I was to extend it just to see the 90-degree angle, it will reach. So what I'm going to do, I'm going to multiply 7.3 times 8.3. And I get 60.59. So let me write this thing down. I went 7.3 times 8.3, and my answer was 60.59. But I have to round it to the nearest tenth. So the second decimal place is big enough, so pushes the 5 over it. So my answer will be 60.6. So far, not bad. Okay, so 60.6. But then, let's take a look at question number 3. Triangles. Okay, I know how to get the area of a rectangle. Let me break this from a rectangle. And let's say my rectangle was 6 by 4. Like I said, I'm going to create the formula for a triangle based on the rectangle. And let's say this is 6 by 4. So we know the whole rectangle is 24. However, I cut my rectangle, cut it in half. So let me just say that each of these halves is 12, right? Because the whole thing was 24. Interesting, though, is that half of a rectangle, if I pay attention to it, half of a rectangle is a triangle. I only needed the two numbers that make the 90-degree angle. The longest side, the hypotenuse of my triangle, I did not use. Now, my 90-degree angle in a triangle sometimes is at the corner of the triangle, like we see it now, sometimes inside of the triangle, sometimes outside of the triangle. I'm only going to use the two numbers that make the 90-degree angle. If you notice, I multiplied them and then divided by 2. We divided by 2 because a triangle is half of a rectangle. All right, so I look at my 90-degree angle here. It's right there. It is made by the measurements 2.8 and 4. Notice I don't have to use every number given. Okay, so 2.8 and 4. So I'm just going to multiply those out. So 2.8 times 4, but then I'm going to divide this by 2. Remember, I divided by 2 because a triangle is half of a rectangle. Use a calculator if necessary. It gives me, to see, 2.8 times 4 divided by 2. It gives me 5.6. It's already given to me as a 1 decimal place, so that's good. Don't have to round it. Let's take a look at question number 4. This is a trapezoid. Okay, interesting on the trapezoids, two sides are parallel. Let me call one side base 1, and let me call the other side base 2. They're not quite the same length, but let me call them base 1, base 2, the two sides that are parallel. Right? And then it has two other sides. Let's just say that the height of this trapezoid, for right now, let me call it h. Have no idea what it is, right? So let me call it h for the height. The cool thing on trapezoids is, imagine I cut it in half. So I came over, and let me do this with white. Let's say I cut this in half. On the top, I get another trapezoid. The bottom half is another trapezoid. So I basically cut into two different trapezoids. But let's say the trapezoid on the top, I flip it upside down and put it next to this trapezoid here. So let me put the trapezoid that I have on the top. Like I said, I flip it, put it down. So now this part right here, it is base 1. Now let me highlight the figure that I just created. I created a parallelogram, right? We just mentioned in question number 2 that parallelogram, we're going to treat it like a rectangle. I'm just going to multiply the two numbers that make the 90-degree angle. So notice the long side of this place is base 1 plus base 2. Notice I added the two bases. But then I have to go times height divided by 2. Notice how the height of my parallelogram is half of the height of my trapezoid. Okay. And the bases, base 1, base 2, are the two numbers that are parallel. So looking at number 4, the two numbers that are parallel are these two. So I'm just going to go 0.7 plus 1.9. Have to worry about that first. So base 1 plus base 2, the two sides that are parallel. And then the height is basically the distance between the bases. In this case is 1. You guys can see the 1 here. My second parenthesis, I'm going to go 1 divided by 2. So remember, I have to cut the height in half. Now, can grab a calculator. 0.7 plus 1.9 is 2.6. So my first parenthesis is going to be 2.6. The second parenthesis, 1 divided by 2. My calculator says 0.5. And then I can just multiply that out. 2.6 times 0.5 is 1.3. That's not that bad. Let's take a look at a rhombus. Rhombus, all the sides are equal. My angles are not necessarily 90 degrees, so it's not a square. Right? This is just a rhombus. The interesting is that I'm giving you measurements of the diagonals. Diagonals are those dotted lines that go inside my rhombus. And I'm even giving you guys a side of the measurement of one of the sides. Now I'm going to say you don't quite need to use all the numbers. If I was to look at a rectangle outside of the rhombus, let's imagine this rectangle. Interesting is that this rectangle is a 4 by 7. So the whole rectangle is 28, right? The whole rectangle is going to be 4 times 7. But let me focus on one piece of my rectangle. And it seems like I only need half of that piece. Okay, let me look at another part of my rectangle. And it seems like I only need half of that. And then let me look at another piece of my rectangle. I only need half of that. And this last piece, I only need half of that. So it seems like I had the whole rectangle. So let me just go 4 times 7. I had the whole rectangle. However, I only need half of it. So when it comes to a rhombus, I'm going to multiply my two diagonals. And then I'm going to divide this by 2. Okay. Use a calculator if you need to. 4 times 7 divided by 2, it gives me 14. So when I have a rhombus, again, I multiply the diagonals and then divide it by 2. Interesting part is when it comes to a kite, I'm going to do the exact same thing. Let me just highlight that I have a rectangle outside. In this case, my rectangle is 6 by 6.4. But now, just like it happened with the rhombus, the kite is only half of my rectangle. So I'm just going to go 6 times 6.4, right? Because that's going to give me the whole rectangle. But since I only need half of the rectangle, whatever I get, let me divide this by 2. Use your calculator if you need to. 6 times 6.4 divided by 2, it's going to give me 19.2. So the first part of our homework is just going to be get the area of figures. Pretty simple. But then once you know how to get the area of the figures, we're going to play with that. Let's take a look at question number 7 through 10. When I ask you find the missing measurement, round your answer to the nearest tenth. In this case, number 7, I'm giving you a rectangle. And I'm telling you the area is 27. One of the sides of the rectangle is 5.2. And then another side of the rectangle, 5.2, but the third side is a question mark. We learned back in algebra that when we don't know the value of something, we replace it with the letter. So let me call this x. All right, find the missing measurement. I'm saying it is x right now, so I'm just gonna solve for x. I know that for the area of a rectangle, I choose a 90-degree angle. I'm gonna choose this 90-degree angle. It's made by the measurements 5.2 and x. I have to multiply those two out. So I'm just gonna go 5.2 times x, and it's equal to the area, in this case, 27. Right? Gotta solve for x. So let me divide both sides by 5.2, because I want the x by itself. Let me divide by 5.2, because division is the opposite of multiplication. So I get x is equal to, according to my calculator, I get 5.19. There's more decimals, but I'm running to the nearest tenth, so I'm just going to look at 2 decimal places. The 9 is big enough, so it pushes the 1 over. So my answer would be 5.2. Okay, so that side was 5.2. Let's take a look at question number 8. That's a trapezoid. This question mark, let me replace it with an X. Now remember, I said for the area of a trapezoid, right? We saw that in question number 4 of our notes. So I said for the area of a trapezoid, add the 2 bases, and the bases are those 2 sides that are parallel. So I'm just gonna go 4.7 plus x. I said add the 2 bases. And then whatever you get, you're gonna multiply it times the height divided by 2. So 9.1 divided by 2. Right? The height is the distance between the bases. And that should give you the area. In this case, I'm told that the area is 67.3. So all of this should equal to 67.3. Okay, so let me solve for x. The first parentheses, 4.7 plus x, nothing I can do. So let me just call this 4.7 plus x. The second parentheses, 9.1 divided by 2, let me just call that 4.55. And this is all equal to 67.3. Okay. Let me get rid of one of my parentheses, right? Because 2 parentheses together means multiplication. I can do the distributive property, but I can also just divide both sides by 4.55. So this cancel out. So I get 4.7 plus x equals now 67.3 divided by 4.55 is equal to 14.79, and I'm gonna do dot, 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 dot. My calculator says 14.79120879, and I left that on my calculator because I'm just gonna subtract 4.7 from that. So I'm gonna keep that, whatever I have, I'm gonna keep it on my calculator. I'm just gonna go minus 4.7. And it tells me 10.09. This 9 is big enough, so it pushes the 0 over. My answer will be 10.1. Looking at question number 9, that looks like a rhombus. So I remember for the area of a rhombus, I multiply my 2 diagonals. I see one of them is 12, the other one is x, right? It's a question mark, so I don't know what it is. I remember I multiply my 2 diagonals, 12 times x. And then I divide it by 2. So let me divide this by 2. And all of this is going to equal to the area, which is 44.4. Couple things I can do here, but one of them, first thing I can do is get rid of fractions. Okay, so let me multiply both sides by 2. If you don't like fractions, get rid of them. So I have 12 times x is equal to 88.8. All right, I went 44.4 times 2. Now 88.8, to get x by itself, let me divide both sides by 12, because that way the x stays by itself. Use a calculator if you need to. 88.8 divided by 12 gives me 7.4. Okay. Now for a kite, right? That's a kite. For a kite, same thing I did for a rhombus. I'm going to multiply the two diagonals. I see one of my diagonals is 2, the other one is x, right? I don't know what it is, so I'm going to call it x. So I remember I have to multiply my two diagonals, so 2 times x. Whatever I get, I have to divide it by 2. That's going to give me the area. It says the area in this case is 5. So I have 2 times x divided by 2 is equal to 5. Couple things I have to do here, but what I could do, one of them, get rid of fractions. Let me multiply both sides times 2 just to get rid of the fractions. So I get 2 times x is equal to 10. So there's a couple other things you could have done, but I'm just gonna keep the same structure, so same steps. Just get rid of fractions. So I have 2 times x equals 10. Then I'm gonna divide both sides by the number in front of x. So I get that x is equal to 5. Now this is pretty simple, right? When I'm giving to you guys just one figure, I could give you guys triangles, I could give you guys trapezoids, I could give you guys parallelograms, rectangles, right? Any figure that we work, right? I gave you guys the different figures that we have. I gave it to you guys in examples 1 through 6. Notice that from 7 through 10, I only did 4, but it could be any of the 6 that we did. Another thing I'm gonna do is I'm gonna give you what we said composite figures. Now, composite figures is that I'm gonna combine two figures into one. But those I'm gonna let you guys practice on your work. Now, how could those look like? Let me just say that I could give you a trapezoid, and on top of the trapezoid, I could add a rectangle. The way you will see it to begin with is not gonna be broken down like this. It's gonna look something like this. But you have to be able to break it into figures that you know. So composite figures, I'm going to give you some figures in there. I'll give you the measurements that you need. So the measurements will be given, but I'm going to put figures that we know to create other figures. And when I say figures that we know are from the first 6 that we did. So I could use rectangles. Obviously a squared is a rectangle. So I could use rectangles. I could use parallelograms. I could use triangles, trapezoids, kites, and rhombus. So you're gonna play with composite figures. Like I said, just break it down into figures that you know. Now, another thing we're gonna move on to finish this lesson is what we call polygons or regular polygons. Now, poly means side. That's what poly means. Poly means sides. And then regular means all the sides are equal. Okay. So we're going to be looking at area of regular polygons. First example I'm going to use is we're going to be using the apothem. The apothem is this distance from the center of the polygon to the center of one of the sides. Now, I said polygon is poly. Actually, poly means many. You guys learn in Algebra 1 polynomials, many terms. Poly means many and gon means sides. So polygon will be a figure with many sides. In this case, question number 11, we see a figure that has 7 sides. Okay, now regular means all the sides are equal, and I want you to round your answer to the nearest tenth. I want you to find the area of this polygon. Okay, I said all the sides are equal, right? Key phrase regular. So I'm gonna say this measurement right here is 13.9. One thing that I know how to figure out is the area of a triangle. So what I'm going to do, I'm gonna break this polygon into triangles. Let me focus into one of my triangles here. Let me highlight it in blue so you can see it. I'm looking at this triangle. The two numbers that make the 90 degrees are 14.4 and 13.9. I know for the area of a triangle, the area of this triangle, I'm gonna go 14.4 times 13.9, and whatever I get, I'm gonna divide this by 2. That's gonna give me the area of that triangle. Interesting part is, let me connect the center with each corner of my polygon. We said this, let me highlight the one triangle that we can figure out. That's one triangle. This is 2, 3, 4, 5, 6, 7. This figure has 7 triangles. I know what's the area of one. All the triangles here are the same side. So to know what's the area of all 7, I'm just gonna get the area of one, and whatever I get, I'm gonna multiply this by 7. Now 7 is not just a random number. 7 happens to be, if you notice, is how many sides the polygon has. So for future reference, if my polygon has 5 sides, I'm gonna get the area of one triangle and multiply by 5. If my polygon has 9 sides, get the area of one triangle and multiply by 9. So in general, I'm gonna get the area of one triangle and multiply by how many sides there are. Now this one, I'm just gonna type in on the calculator. I'm just gonna go 14.4 times 13.9 divided by 2 times 7. So notice I just went straight as I read this. 14.4 times 13.9 divided by 2. I didn't have to press equal. I just went times 7. My calculator tells me 700.56. But I have to round this to the nearest tenth. So the second decimal place, it is big enough, so pushes this 5 over. So my answer will be 700.6. So using the apothem is not that bad. Let's take a look at number 12. I know each side is 12.9 because it's a regular polygon. So I'm gonna say this side out here is 12.9. I see I create a triangle here. I'm gonna get the area of that triangle. And for that triangle, I'm gonna go 8.9 times 12.9 divided by 2. So it's gonna give me the area of that triangle. And whatever I have, I'm gonna multiply this by 5. And 5 because there are 5 sides. So let me go 8.9 times 12.9 divided by 2 times 5. And my calculator says 287.02. Take a look at the second decimal number. It is too small, so I'm going to ignore it. So I can call this 287.0 or just 287, whichever one you want. 287.0 or just 287. The 0.0 can be ignored. So when we have the apothem, it's nice. Now when we don't, here number 3, I don't have the apothem. So here I'm going to have to rely on special right triangles. Remember we saw those last week. Special right triangles, the 45, 45, 90, and the 30, 60, 90. Okay, so let's take a look. What I'm going to do, I'm gonna put a center here. Let me break this into triangles. I know, let me do it in red right now so we can highlight it. I know there's a circle here in the center. I know I can break this 360 divided by 3. I can break that there. But instead of that, let me just come in each of my triangles here. Let me cut it in half. Now I have 6 triangles there. Again, I have a circle here, so that's 360. If you notice, I have 6 corners. Interesting part is that they're all the same side, the same angle. So I'm just gonna go 360 divided by 6. So I'm gonna say each of these corners is gonna be 60 degrees. So let me just call this 60. Here's a 90. Now, this side, I see one side here is 8. So the half of 8, because notice how I cut it in half. Let me call this 4, and this is 4. Let me focus on this red triangle. I'm going to highlight it in red so you can see which triangle I'm looking at. One angle is 60, the other angle is 90. So I'm going to say this angle is 30. So matter of fact, for these type of question, when you guys are going to be finding the area of regular polygons using special right triangles, you're either going to get a 30, 60, 90 triangle or a 45, 45, 90 triangle. Now I remember how to do 30, 60, 90. I don't need the hypotenuse in this case. I need the small side and I don't have it. I remembered on the 30, 60, 90, let me highlight it over here. If I had the small side and I want to get the medium side, I had to multiply this by radical 3. So because I'm going backwards, notice how here I want the small side. I'm going to say this small side is 4 divided by radical 3. Okay, so now I have the apothem. I just figure out what the apothem is. 4 over radical 3. I know for questions 11 and 12, I gave you the apothem. Here for question number 13, you had to find out the apothem. So now let me focus. Let me highlight this in green. Let me focus on this green triangle. I can find out what's the area of that green triangle. I'm just going to go 4 divided by radical 3. I have a calculator. Calculator can figure that out. So 4 divided by radical 3 times 8. And whatever I get, I divide this by 2 because it's a triangle. So 4 divided by radical 3 times 8 divided by 2. My polygon has 3 sides, right? So whatever I get for that triangle, let me multiply this by 3. So let me bring a calculator. So my first parentheses, let me open it up. I'm going to go 4 divided by the square root of 3. First, close the parentheses for the square root and then close the parentheses for that. Make sure you have double closing of parentheses. Notice how I had 2 parentheses open. Make sure you close both. So I have 4 divided by square root of 3 times 8 divided by 2 times 3. That's what I had. That's what I had on my work. 4 divided by square root of 3 times 8 divided by 2 times 3. I press equal, and it says 27.71. So 27.71. My 1 is too small, so I'm going to ignore it. It's just 27.7. All right, let's take a look at question number 14. I see the center here. And I'm going to break my figure into triangles. I'm going to go to each corner. Not only that, but each of my triangles, I'm going to cut it in half because I'm going to come out with the apothem. So I'm going to go here, 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 and here. I count how many corners I have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I'm going to go 360 divided by 12. So that's 30. So I'm going to say this is 30 degrees. Let me focus on one triangle here. That's 30 degrees. This is 90 and this is 60. And this small side is going to be 5. You see how the big side was 10 to begin with, but I cut it in half. So the half of 10 is 5. So the small side of this figure is 5. I'm going to say this apothem. Remember the 30, 60, 90 triangles. I'm going to say this apothem is 5 times radical 3. Because remember, the small side times radical 3. Cool. So now let me focus on just one big triangle here. So I'm going to use the apothem for this big triangle. What I'm going to do for that triangle, I'm going to go 5 times radical 3 times 10. So I have to multiply my two sides divided by 2. That's the area of that triangle. Like I said, I can type it in, so not a big deal. My polygon to begin with had 6 sides, right? So whatever I get for one triangle, let me multiply this by 6 because there were 6 sides. So let me bring my calculator out. Now, to be honest, you have degrees on radians. It doesn't really matter now because we're not dealing with angles. So it doesn't matter. I have it on degrees, but if you have it on radians, you get the same thing. So let me say I have on top of my fraction, remember I have 5 times square root of 3. Make sure you close that parenthesis for the square root times 10. You guys might be wondering, why am I not using parentheses this time? It's okay. Like if you want to just type it in all together. That's what I had on top of my fraction. Remember, I had 5 times square root of 3 times 10, and then divided by 2. Right? If I do this, this gives me the blue triangle that I had. But whatever I get, let me multiply this by 6. I'm going to multiply by 6. And it gives me 259.80. Okay, so 259.80. The second decimal number is too small. I'm just going to ignore this. So 259.8. Beautiful.